Hello, thank you for joining us for episode 8 of our webinar, Scaling Your Insight Delivery. My name is Don, I'm here with Sam. Sam's going to be presenting today's webinar and sort of giving you a bit of insight into how you can customize your extraction, implementation, integration, promoting finding value and bringing more data into the decision-making process. We both work at a company called Keboola. What is Keboola? Keboola is data management as a service. So what we've done is we've built the architecture, the integration, the preparation, the governance, which means your developers and your analysts are allowed to work together simultaneously. Now for a bit of housekeeping. This webinar is going to last about 20 to 30 minutes. Please email in your questions, because what we'll be doing at the end is responding to them and sending out the answers with a copy of this webinar. All right, well, with no further ado, I'll hand over to you, Sam.
Thanks, Don. So, as we discussed with Don, today we'll cover a very interesting topic of scaling insight delivery with custom components, such as extractors, writers, and applications. This will allow you to bring in more data into Keboola and perform a more powerful data transformations and analysis inside Keboola. Our agenda for today is a brief introduction into components. I'll talk about what they are, why are they beneficial, and who can build them. Next up, we will cover a process of building and deploying a component into Keboola. We'll also try to configure the component with our own parameters, such as input files, tables, etc., and make the component more intuitive with the usage of manifests. And last but not least, we'll talk about the generic extractor, a very powerful tool to extract data from any sane API. So let me start with a question. What actually are components? Components are a very powerful customization tool for Keboola that allow anybody to extend the functionality of Keboola beyond its current capabilities. You might be a business user who wants to convert your business problem into a cloud, or you may be an external company who's looking into allowing all of the KBC users to allow your products and services being accessed, or you may be a data scientist who wants to deliver the results to the customer quickly and efficiently. And components allow you to do just that. There are 4 basic types of components. The first one is the extractor. The name itself should be pretty self-explanatory. The purpose of an extractor is to extract data from outside source and store it in Keboola storage. Writer is the exact opposite of extractor. It makes the data from storage and writes them outside to data warehouse. Applications are a very versatile component. They may transfer the data in some way, or they may not even touch the data. Applications might be the data science related transformations, or just simply a script for sending emails to pre-specified list of email addresses. There are no limits to the imagination when it comes to applications. Processors are very lightweight components, which take a minimal number of parameters and process the data in a particular way. There are 2 types of processors, before and after, depending on time of execution regarding running a Docker image. It is worth mentioning that each component is represented by a single Docker image, which is stored in a private AWS repository. The limitations for each component are 256 megabytes of RAM and 1-hour timeout limit. The picture that you currently see on your screens represents what happens when a component is ran. Firstly, on the right-hand side, we have storage, which is responsible for input and output tables and files. It communicates with other applications via storage API. On the left-hand side, we have a Docker runner, a single most important component of Keboola. Docker runner is responsible for authentication, so that no component is run unauthorized or anonymously. Moreover, the runner communicates with storage via API and is responsible for reading and writing tables to and from storage. The runner is also responsible for running components in separate containers. Container is a form of sandbox that does not allow a component to make changes to the image. This is very important as it ensures that whenever you run a component, its run will not be affected by the previous container. The workflow of the whole process is following. A specific Docker image is downloaded and built. Concurrently, all necessary files and tables are downloaded from the storage. Next, a configuration file is created, which contains information about parameters, input mapping, and expected output mapping. Firstly, before processes are ran, if any are present, followed by running a Docker image and creating a container. After processes are applied next, and files and output tables are written to the storage afterwards. The process ends with deletion of container and all temporary files. Now, let's go over a build and deployment process. If you want to deploy a component into KBC, you need to be part of our developer program and to be or join a vendor, a group of developers. This is a rather very simple process of creating an account and applying for vendor registration by answering a few questions. Due to simplicity of the process, I will not cover this, but instead you can find a link in useful links section on how to create and apply for vendorship. Another necessary thing is an account on GitHub or Bitbucket or any other Git repository service, and integration with Travis CI or similar. This is necessary so that components can be deployed into our AWS repository and into KBC. Most components are developed locally, and for that reason you will need a Docker to simulate the KBC environment and see the behavior of your component before its deployment. The whole deployment process is split into 8 parts. First half is rather easy, the second half might be more challenging. So let's start with number 1. Number 1 is registering a component. We can do so by going to components.keboola.com, and in our account section, in the upper right corner, we can add a component. In this webinar, we will be building an application which will duplicate rows in an input table. This is a highly fictional application. Its usage in real world is rather limited, or rather non-existent, but it's a great way to showcase the abilities of applications. So let's select a type. This will be application. The name of the application might be webinar -demo. Here you can see that we are provided with a unique ID which points to our application. The first part of the ID is our vendor name, which in my case is my surname. The middle part is the type of component, followed by the name of the component. This ID will be really important in later stages when we'll try to access our component. To deploy the component, you will need credentials. For security reasons, it's not advised to use your real credentials, but create a service credentials instead. You can click on service accounts over here on the top right. By clicking here, you can add or create a service account. You can specify the name, so in this case, let's call it a webinar, and create an account. In the pop-up window, you will be provided with new credentials. These credentials will be shown to you only once, so make sure to note it down somewhere that you will not lose them. Number 3 on the list is create an empty GitHub repository. So let's navigate to my GitHub. Let's click on new. And it's a good practice to call the repository in the same way as your second part of your application ID. So in my case, it will be app/webinar-demo. We can initialize the repository with README and create a repository. Number 4 is to clone the repository for local development. This will essentially connect your remote and local branches. So let's just clone this. Let's navigate to my GitHub folder. Let's do git clone, and now the Git repository is cloned. So let's move on. To create a component structure, we'll use a component generator tool with the below command. The command will create all the necessary files needed for deployment. So let's just switch to our terminal now. As you can see, I have a docker run command here, which will mount the volume, more specifically the folder where my GitHub repository is located, and it will use this image to build a file. So let's just press enter now. As you can see, it asks me whether the repository is correct. So yes, in my case it is. We'll create a very simple Python application. So as you can see, you can also use PHP and R. You can also use any other languages you want, but the script will require some slight modifications, but it shouldn't be an issue. So we'll just press 4 now. As you can see in the background, I have a folder regarding to a GitHub repository. And as you can see, we already have some files created here. Now, it will ask us for whether we want to complete the installation. Yes. And now it's asking for my GitHub login credentials. So let's just log in. And now if everything goes right, it will ask me for the service account credentials. Let's take a look at it. Oh yeah, it's going through. So now it will ask me for a vendor ID. So I'm a registered vendor. Now for the component ID, which as I showed you was composed of vendor ID. There was that. There was a type of application. So in this case, it's app, and the name of the application, which is the webinar-demo. Now the service account name, as I told you, you need to keep these somewhere so you don't lose them. For this one purpose, I won't save them anywhere. And also now the password, which can be copied. And here we go. All the deployment scripts, all the deployment files were created right now. All we have to do now is, as we can see, the command created a tagged commit with tag 0.1.0. To be completely clear, Travis build and deployment of component is triggered by a tagged commit. So what we should do now is simply do git push origin, and let's push it to the 0.1.0 tag. As you can see, the commit went through. Now, if we switch to Travis, we should have some jobs running. And yes, that is it. We can see that our repository app-webinar-demo is being built completely with tag 0.1.0. Now, this may take some time, so I'll just skip to the end of the build process. So coming back to the process, we skipped number 6 because we'll come back to it later. Basically, we use the component generator tool to create a very simple script. If we just take a look at it, you'll see that it's simple hello from world application. Now we did a tagged commit, which triggered a build and a deployment. Now, if we look at the Travis CI log, we can see that the application was successfully deployed. We can also check whether it was successfully deployed in components.keboola.com by going to an account, looking at the application, clicking on edit, and as we can see, there's a tag 0.1.0. Now, how to access the data, the application in Keboola? We can go to just to the applications menu, but we don't see here. So what you do, you can access this by modifying the URL and typing in your ID of the application, which was provided to you and components. And now here it is. So let's just create a new configuration. Let's call it test, and let's run it. Since the Python script was a very simple hello from Python world, we should see a message being printed, and which is exactly the case. So we just deployed our very first component. So congratulations to you. So how do we get the parameters and input tables into our component? Well, first things first, we'll have to rewrite a component so that it actually does something. Currently, our component just prints a hello world from Python message, which is not very useful. So we'll do that at a bit later date. First, I would like to introduce the concept of parameters, input tables and input files, and output tables and output files and manifests. Parameters are basically just arguments that are passed to the component and that have an effect on its behavior. When developing, you can specify as many parameters as you'd like, but generally, the less the better. Otherwise, the whole component might just become very confusing for both you and the user. Every parameter preceded with a hash symbol, it will be automatically encrypted. This is a great feature for sensitive information such as passwords and API tokens, so that they are not left in the wild. To demonstrate that, I can go back to the application that I created before, and here I have a simple config file. As you can see, I specified a hashtag password parameter, which is not defaulted yet. Once I click on the save button, the password will automatically encrypt. So let's just do that. Voila! As you can see, the original password is nowhere to be seen and it cannot be used anymore. Now, input and output tables and files come from the storage, and they can be very easily specified in the mappings. By default, the mappings are not allowed, but you can very easily enable them in component specification. So let's just do that. Let's go to components.keboola.com. Here's a component we created earlier. Let's just hit edit, and under the UI controls, oh, where is it? Oh, here. We can specify the UI. So for this task, we'll just need a table input. But you have many others. You have file input, file output, table output. You have processors, etc. So let's just hit save. Note that once we do some changes to the component, doesn't matter whether they come from the components.keboola.com or it's a new build of a component with totally different code, it might take up to 5 minutes to propagate the changes into KBC. Now, manifests. Manifests are files which contain metadata about input and output tables. In our example, we will not dig deep into these. Instead, we will use them to automatically store our output table into KBC storage by specifying the destination of the table. There's a whole lot of possible combinations in manifest files, and I'll leave a link to a useful documentation about manifest files in the useful link section. Now, to locally create a component, you will have to create a directory similar to that of KBC. Thankfully, the component generator tool took good care of that, except for data folder, which is crucial in our task and it's currently missing. It's best to create the data folder in the same folder as your code, but beware, never upload the data folder anywhere. The data folder might contain very sensitive information, such as the API tokens or various passwords in the config.json file, and which might be abused at a later date. The structure of the data folder should be as I specified on the screen right now. So as you see, we have a data folder, and in it we have two folders. We have in folder and out folder, and where we have a config.json file. In folder, there are in files and in tables. The in files are basically files which are inputted at the beginning of the application run. In tables are tables which are inputted at the beginning of the application run as well. Out is the exact opposite. That is what's coming out of the application, or an extractor or a writer. It doesn't really matter. Config.json contains parameters, specifications. I will not cover config.json in very much detail. Again, there is a lot of possible combinations in config.json, but I will leave a link in the useful link section. Before a short demonstration of code, I would like to introduce you to a very useful commands, especially in Python, related to Docker. So first one is basically importing the Docker package from Keboola. The second one specifies the class of commands and sets the working directory data folder. Next one is the get parameters. This one reads the config.json file and fetches the parameters. The output is the dictionary, which can then be subsetted. Then we have the get input tables, which again is a list of tables with their full path to the target folder. Then we have the input files, again the same thing as tables but with files. And then we have a write table manifest, which writes a manifest file, which we will use in this demo. So now, let's go to a short demo. Now, as you can see here, I've created data folder. As I mentioned, it is very important not to upload the data folder anywhere. Hence, the first thing I always do is go to gitignore and add the data folder. Just to be safe, I also add config.json. If anything, you never know when something will go wrong, but the config.json will therefore never be uploaded anywhere. Secondly, let's take a look at the Docker file. The Docker file is in charge of building a Docker container. As you can see, the data is not specified anywhere. Here we see that we are setting a working directory, but we are not creating or copying the data into the working directory. So what needs to be done is add the following command, which you right now see on screen. It is the copy data to data. This will copy the data folder from our local, which basically I created myself, and I will copy it to Docker container. We specify the data folder not to be uploaded anywhere, this will not be present during the Travis CI build. So it is very important that when you're developing the application or the component, it is okay to have a line present in Docker file. But once you're trying to push the component into Git and then follow up, trigger a Travis build, this data folder will not be present. It is therefore very crucial that when you're running a git push, comment out this line and save a file. The build would otherwise fail. In this case, it won't, because the data folder won't be copied since it's not there. Now let's revert back because we're trying to develop an application. Now let's go to main.py. Main.py is a very simple application that I created. It basically takes in an argument a number of times and copies, basically duplicates every row in an input table and then writes out. So let's take a look at config.json. As you can see, we have parameters here. I specified that I want the number of times to be present. If you want more parameters, there's no problem. You can just create them. Let's just say, as I specified before, let's just say password, and we can assign a value to it. But we won't be using it, so I'm not going to do that at the moment. I just save that. As I said, the first two commands are very important to fetch the parameters and the set working directory. Next up, we'll just subset the parameters that we fetched and assign it to a variable. Now, if you want to, you can basically use the get input tables to fetch the input tables from the config.json file. As you can see here, I specified a table with destination input.csv, and it is also present in input.csv plus its manifest. This input table will be provided with its full path, as you can see here, which will be a result of this command. So now I'll just load data in. As there is only one input file, I will just subset the first iteration. If there will be multiple, you would need to create a loop basically. And now onto the stuff. Just a basic duplication using the number of times parameter that we specify from config.json. If we want to write out the CSV file, the data frame that we created, we just need to do the data to CSV and specify the data/out/tables folder as the output folder and name the file. Now, as I said, we will use manifest to automatically save the resulting table in our Keboola storage. You can do that by specifying the full path to the folder and then specifying this destination parameter. The destination parameter marks in what bucket and what table you want the resulting table to be saved in Keboola storage. It is always good to end the script with print done, so you know you're done. Let's just take a look at what this application does and see the resulting data. So We just run the terminal, and now what we'll do is docker build. We use the T, which stands for tag, and the docker file, which is the image we want to build. Dot specifies the current folder, and docker run docker file. Docker file. Now I'll just simply run it. Now, as you can see, the image is pulled, the data is copied, etc. And the output is the components are great 4 times. That's because we created 3 duplications and 1 was already there, which is great because actually our input table had the phrase we wanted to copy, and it did just that. We don't need the print data for the production version, so we'll just get rid of it. And also, we'll just comment this out, as I said earlier. Now, let's push this into the KBC. So we'll just use git add all, get commit. I'll just add a comment message. Now we'll just create a tag, so we see that there's only one tag, the one we created earlier. And we'll just do git push origin and do it back. Now this will trigger a build as before. So if we go to Travis, we can see here that we already have a tag for 0.141 and it's being built. Now, some 5 minutes later, after the build finished, we can see that the application was deployed without any errors. So I left it some time to propagate the changes into KBC. So now our application should be ready to be tested out. So let's look at the application. As you can see, the table input mapping field was created, which was the result of us specifying it in UI sections. So I just select one table. I select the webinar demo because I prepared it. In this case, it doesn't really matter what you will call the file, because we use the docker command to fetch all the input files and give us the full path to each of the tables. So it doesn't really matter in this case. Which I specified the number of parameters. The parameter, which is in this case number of times, I set it to 10 just to demonstrate how the parameter works. So let's save this configuration. Now, if you run it, our expected output is the table with 11 rows, and which will be automatically saved to Keboola storage. Now, as we can see, we can observe the log files. Now it is inputted, and here is the print done message. Therefore, the script was done. And as we can see, the table was imported into out C webinar demo, just as we specified in our application. Now, if we take a look at our, we see it has 11 rows. Let's just look at the data sample, and it is 11 same rows. So everything is working just as expected. Now, the component that we created today is a very simple. It is just a demonstration of what can be done. Usually, extractors and writers and applications are much more complicated. Basically, you can specify any code you want, and these hardcore applications require more coding in general. It's always best to read the documentation to the components you are using, because some might be very sensitive to changes. And also, it is very important to read the documentation of the component to which the service to which the component you are creating. For example, if I am creating an OneDrive extractor, I would need a OneDrive documentation to configure the API calls, etc. Now, the last thing I want to talk about is generic extractor. Generic extractor is a very powerful tool in Keboola. So Genex is a customizable HTTP or REST API client applicable to any sane API. With proper API documentation, you can have a new configuration done within an hour. The Genex offers endless possibilities of configuration options such as pagination, authentication, mappings. It also supports loops and functions such as what to do with empty values, what to do with with blank, how to convert date to string, etc. In fact, I can show you the complete config of the generic extractor. Here, as you can see, it's pretty long. But don't be scared, it's very easy to configure the generic extractor. Now, the generic extractor is very advanced. It is able to extract a JSON file and configure it to CSV. I won't talk about the generic extractor in more detail, as it is. There are multiple configurations again, and we have a great tutorial on developers portal. Moreover, if you configure a generic extractor to a certain endpoint, you can publish on configuration for everybody else to use. Just to recap, so what we did today, we built and deployed a component. First it was very easy. Then we adjusted the component source code to meet our needs. In this case, it was just a duplication of rows. We configured the input tables, which were to be duplicated. We configured the parameters and wrote the table to storage using manifest file, thus making it automatic. Then we briefly talked about generic extractor as a god of all extractors. Now onto the useful links. The first two links are basically about extending the Keboola with components. They are very good documented tutorials. The second link about Docker Runner explains what actually is a Docker Runner, so you can grab that intuition behind it. Then we have the third block is about input mappings, output mappings, and a config file. Especially the third link is it shows many different configurations of config files. Then we have manifests. As I said, those are very they contain metadata, and they have there are various combinations as well. So it's useful to check this out. You can also create a custom UI. So if you see something like this, sorry, let me just go back. If you see something like this and you don't like how you have to use a JSON to specify the number of parameters, you can use a JSON schema to specify a UI. For example, I can show you a very useful link, which is also included in here as a JSON editor. You can make your UI look something like this, and this will be the output of it. The source code is here. You can just update schema and it will update automatically. It's great for testing, for creating UI for Keboola components. Then we have a documentation about generic extractor. I showed you many different variations of mappings, of functions, etc. And the last one is a Docker Runner API. This one is great for debugging and running jobs. I would suggest you go over it and familiarize yourself with some commands. I would like to thank you for tuning in and listening to me. Our next episode will be about A/B testing and conversion ratio optimization. It will be presented by a great colleague of mine, so make sure to tune in. If you have any questions, don't hesitate to contact me. Here is my email and my numbers. I will personally respond to any questions and send out a copy of the presentation as well. So thank you very much for joining me, and see you next time.
Well, thank you very much for that, Sam, and thank you very much for listening in. As stated earlier, please send in your questions because we will be responding to them with a copy of the webinar. Also, in addition to that, feel free to share it with anybody else you think may find it of interest. And tune in next week to our A/B testing and conversion rate optimization webinar. Thanks very much. Cheers.
Thank you very much.